Here is an application of mean value theorem. What does mean value theorem says? If f is continuous on the closed interval, f is differentiable on the open interval, then there is a c in the closed interval such that f prime c is equal to f of b minus f of a divided by b minus a. Let's read our problem. It says it's given that f of 1 is equal to 10, and it also claims that f prime of x is more than 2 for this interval. So when they're saying f prime of x is more than 2, that clearly means for this interval 1 to 4, because they said from 1 to 4, f prime exists and is more than 2. If it exists, we can claim that f is differentiable on the closed interval 1 to 4. And differentiability always implies continuity, so therefore f is also, that implies f is also continuous on the closed interval 1 to 4. So both the conditions of MVT are checked, verified. So we can claim using our conclusion that there is a C in the interval such that f of 4 minus f of 1 by 4 minus 1 is equal to f prime C. But we said f prime is always more than 2. So f prime of C will also be more than or equal to 2. That means what we can say is f of 4, which we do not know, but f of 1 is what? 10. Divided by 4 minus 1 is 3. This whole number, which is equal to f prime c, should be more than or equal to 2, because f prime c is more than 2. If we multiply on by 3 both sides, f of 4 minus 10 should be more than 6. F of 4 should be more than or equal to, adding 10 on both sides, 16. What does that mean? The smallest possible value of f4 can be 16. So smallest possible value of f4 should be 16 using MVT. Here is another application like that. Given the question is, suppose f prime x is between 3 to 5. So when they are claiming that f prime x exists between 3 to 5 for all values of x, what does that mean? That f prime exists first of all, right? Then only it can be between 3 to 5. That means f is differentiable. What does it mean f prime exists? That means f is differentiable for all x, and differentiability implies continuity. Therefore, f is continuous everywhere because it's for all x. So we are good, right? Now, then I read the question, show that 18 is less than f of 8 minus f of 2 less than f of 30. Both the conditions of my MVT are checked. That means I can apply MVT, but which interval to apply on? I see that f of 8 minus f of 2, so I should think that gives me a clue that I'm looking for this interval. So that means there exists a C belonging to this interval such that f of 8 minus f of 2 divided by 8 minus 2 is equal to f prime C. But we know all f prime is always less than lying between 3 to 5. Therefore, we can claim that f of 8 minus f of 2 divided by 8 minus 2, because f prime c should also lie between 3 to 5. That means this number also should lie between 3 to 5. Okay, so let's see it one more time. F of 8 minus f of 2. 8 minus 2 is what? 6, between 3 to 5. If I multiply everywhere by 6, I'm doing that to cancel the 6 out. It does cancel, so f of 8 minus f of 2 lies between 18 and 30, which is what we wanted to prove. So we got that statement using what? Using MVT. So this is another kind of application of MVT like that example.